Hello, nice to meet you guys. And I'm a Yuichi, CEO at Y Motion, and Y Motion is one of the company which is really focusing on automotive cybersecurity, and we are now providing so many services focusing on automotive cybersecurity. For example, penetration tests against the development phase car, or threat analysis in developing some product in order to get security level increasing. And today, in this session, I'd like to talk about the security and safety in the modern vehicle. A modern vehicle, the word of modern vehicle is actually including the connected car and autonomous driving car and the other vehicles with the capability of cutting edge like connected or autonomous and like so on. And as you already know, the number of the car which is connected to the internet is getting increasing recently, and we have to implement so many security functions onto that kind of vehicle. And the risk is getting higher. And this is today's agenda. Let me begin with this session with softwareization. This is a really important, really serious problem, a serious component which is going on inside of the automobile market. And the next thing is the software is not protected. To be honest, the level of the security which is now implemented onto the vehicle is not so high, is not sufficient to protect against all of the cyber attacks. And the third one is a case. Case is a really important word for your deeper understanding for connected car and the autonomous driving car, which is what is going on the automobile industry. And the first thing is case study of hacking. And the lastly, I'd like to explain our summary of this session. So the softwareization, firstly, we have to understand the softwareization. This is a really important thing, and actually this is really interesting information from Codebases. The Codebases is one of the websites which is providing so interesting information regarding information itself. They are trying to visualize some of the information, and in this session, I'd like to introduce you guys the volume of the source code. I mean, the number of the lines of the source code, which is used for each applications and system and so on. The first, on the top of this picture, please take a look at this, and that we can find the simple iPhone game apps on the top of this picture. And we can find the volume, the lines of the source code for simple iPhone game apps nearly 10,000. It's really small. And actually, the size of that is really close to a Unix version 1. And the more interesting thing is we can find the space shuttle second from the bottom. And according to this website, in the space shuttle, nearly 400,000 lines of the source code are existing. And turn to the next page. We can find the US military drone, the third from the bottom. And according to this website, nearly 3 or 2 million lines of the source code are existing. And next, we can find Boeing 787 in the middle of this picture. And we can find on the bottom of this picture, we can find F-35 fighter jet. And as you know, F-35 fighter jet is trying to implement and applying their really digitalized device onto their cockpit device. And they can already apply the display with the capability of touch panel functions onto their cockpit in order to sharing the information easily with some of the colleagues. And more importantly, F-35 F-35 fighter jet can improve their weapon skills by updating their firmware. This is really epoch-making skills. And the next thing is, finally, we can find the car software lines of the source code of car software, the second from the bottom. This website is saying, according to this website, inside of the car software, nearly 100 million source code are existing. This figure is nearly double of the Windows Vista and Windows 7, like OpenOS like that. This is a really huge system, or you can say. So we have to protect under these circumstances. This is one of the situations which is surrounding us regarding the connected car and the autonomous driving car. So huge systems are running inside of the car, recently. And next thing is the software is not protected. To be honest, the level of the software, level of the security which should be implemented on the software or system which is running inside of the vehicle is not so high. And in this chapter, I'd like to explain about the reason why the security level is not high, dividing into roughly 3 categories. The first one is desoldering. Next one is plain binary. And lastly, I'd like to explain about the code signing or some of the functions which should be implemented onto the car software. And the first, let me begin with the desoldering. I'd like to show some of the picture. The first, when we're doing the penetration test against the ECU, ECU is one of the Micron which is installed onto a vehicle. First, before doing the pen test, we have to peeling off the IC tip from original microcontroller in order to analyze and in order to extract the firmware which is running on this IC tip. And that we can actually easily peel off the IC tip from original micron board, like using a heat gun or something, and we can melt this solder and we can doing desoldering like this. And this picture is indicating we can really easily peel off the IC tip from micron board. And afterwards, we can put those IC tip onto the other micron board in order to investigate inside of the program and the firmware. And after that, the next problem is coming up, the plain binary problem. And as you can see, this is source code which is based on ARM architecture. And this is source code for a certain IC tip from NXP. The recent IC tip or cutting edge IC tip have some of the function like a secure boot or something. And we actually last year we found some of the vulnerability for buffer overflow on the NX tip on the function of X.509 functions. This is implemented in order to read digital certification for secure boot. And we found vulnerabilities, we found the buffer vulnerabilities inside of this function. And like this, we can find so many vulnerabilities on the IC tip, which is inside, which is running inside of the modern vehicle. And lastly, code signing. And this is one of the really serious problem which is going on the automobile industry, especially for modern vehicle. The most of the ECU, ECU means one of the micron installed inside of the vehicle, and most of the ECU have really poor spec. So most of the ECU cannot afford to run enough security function on them. So obfuscation and encryption and hash validation and security cookies, so many functions which should be implemented onto those icon or sorry, those ICT or those systems, we can know, and we already know which function should be needed for the system like that. But the ECU cannot afford to use or run those security functions as for now. And next thing is case. And case is a really typical word which is going on the automobile industry. The C means connectivity, and A means autonomous, and S means sharing. The last E means electric vehicle. And these four components are really important for your deeper understanding what is going on the automobile industry recently. And let me begin with the EV. It said that tending to electricity is one of the reasons why the number of the cybersecurity incident is getting increasing. But this is not true because the recent vehicle, including airplane and automobile, didn't use only mechanical functions. They are already using the system function already. And when it comes to airplane, the pilot uses a fly-by-wire system. And when it comes to automobiles, the driver uses a drive-by-wire system already. And by-wire system is one of the software-based system, and sending information and receiving information will be a trigger for driven. And for example, let's say if you take a step on the axle, and the system will send a signal taking a step onto on the axle to a system and receiving a system, and then you can drive and you can move forward your vehicle to forward. This is a basic function of the by-wire system. So more importantly, not only the mechanical function will be implemented onto those kind of system, we were already using the by-wire system, software-based system. This is really important. You have to understand that. And then electricity is really irrelevant to a number of the cyber attack. And the remaining three, the connectivity and autonomous and sharing, is really important. And the difficulty of connected car and security for connected car lies on huge scope. We have to protect all of them, ranging from ICT to the system. I mean, we have to take care of the jamming attack and application vulnerability, wireless connection, and vulnerability for system and ICT and microns, and physical hacking and the supply chain risk. And not only that, we have to take care of also network, like a sniffing attack and tampering, DOS attack, and the system. Actually, when it comes to connected car, the IT cybersecurity is just only one component. So that's a huge range. We have to take care of a huge range. This is one of the serious reasons why protecting the connected car is difficult. This is a really serious problem. And the next chapter is a case study. When it comes to a case study for cybersecurity of connected car or autonomous driving car, we have two famous case studies. The one is a Jeep Cherokee. This problem resulted in $1.4 million Jeeps were recalled. And firstly, the hackers tried to hack into the Jeep Cherokee remotely using cellular network, the 3G network. And first, they tried to hack through a TCP 6667 port. This is open to the public, and the hacking the password, and they can succeed to hack into the Linux OMAP system first. And stepping on this system, they are trying to the controller which is running behind the Linux OMAP system. On this controller, B850 system is running, and they can succeed to access via management tool and got root, and they can succeed also override the firmware to their new firmware. And after that, they send some message taking a step on Axel, and then the Jeep Cherokee move forward itself. And this is a really famous case study for cybersecurity of connected car. This Jeep Cherokee. And the next is a Tesla. This is really IT cybersecurity-like method are used. And the hackers are using the CVE, and CVE 2011 was existing on this system. And actually, the Tesla is using the WebKit as the web engine. And finally, they can utilize the CVE 2013 in order to disable armor function on that. And they finally succeeded to override the firmware on the controller. This is a method for Tesla. And like this, we are now hacked into the vehicles which is connected to the internet directly or remotely. But this is hacking for the connected car. We have to take care of it. And the summary is the earlier of this session I told you, the softwareization is really important issue and really important for your good understanding, for your deeper understanding for connected kind of autonomous driving car. And as I told you earlier in this session, nearly 100 million source code are existing for modern cars, including connected car and autonomous driving car. And we have to take care of all of the source code which should be implemented onto the car software like this. So this is really tough. So this is one of the situations which is surrounding us. And I told you the case. Due to the case problem, the ranging we have to take care of is really spreading. I mean, we have to take care of the mic on tip and the ranging from mic on tip to system, including network and the application which is running inside of the vehicles. And as for the network, we have to take care of the sniffing, tampering, and DOS attack, and some of the other incidents which can be assumed in the IT cybersecurity areas. The IT cybersecurity is just only one component when it comes to a connected car or autonomous driving car. This is really important for you to understand deeper on this area. And the Jeep Cherokee is a really famous case study for hacking. And hackers can succeed to hack into Jeep Cherokee remotely, utilizing the port and utilizing open port to the public, and they can succeed to override the firmware to original one. And this is really serious problem. This is leading to a really serious problem. So we have to take care of it. So ranging from ICT to a system, and the IT cybersecurity is just only one of the components when it comes to connected kind of autonomous driving car. Please understand this. Please remember this. So we cannot do and we cannot achieve this goal just only one company. So this is, now I'm thinking, now I'm really considering this is really important for us. Cooperate with us, fight against the hacker and together. Let's fight together. And this is what I want to say in this session. Thank you for listening and enjoy your conference. Thank you.